That's great, thank you. So hello everybody, and thank you very much for joining the How to Develop a Local Heat Project session for our CARES conference. I'm Iona Hodge. I'm the Local Heat Development Specialist for CARES, and my colleague Andrew Morton is helping to facilitate. And we've got 3 great speakers, and I'll just show you the agenda today. So we're going to start off with a recorded session from Scott Mackay, the Midsteeple Quarter project, and he's going to talk about the project that they're doing, which is a town centre regeneration project, and they're planning to use the heat from an aquifer under Dumfries. We'll then hear from David Lindsay-Hood from Locagen Consulting, and he's going to talk about the technical aspects of the Midsteeple Quarter project, so that there's some learning that can be shared with others interested in something like this. We'll then have Lisa Treseder from Kensa Utilities sharing with us progress and learnings to date from the Streets project, the current stage of the heat network market, and future retrofit project plans. After Lisa's presentation, I'll say a little about our planned launch of the new CARES Community Heat Development Programme that Mr. Harvey described this morning. We'll then finish with an open question and answer session, which we won't record, and we'd very much appreciate your thoughts and discussion here. If you have any short clarification questions for the presenters as we go along, please put these in the chat, and Andrea, keep an eye on that, and please keep your microphones and cameras off during the presentations. So thanks very much everybody, and I'll just bring up Scott's presentation now. He's sorry he couldn't come along and be with us in person, but we've got a really enjoyable recording of his presentation. I will take any questions away for him that we're not able to answer today. Just bear with me while I just bring this up.
We can't see or hear anything. I'm afraid it was you and then your dot.
Sorry about that. I'll do that again. You were being very patient. Right, I'm going to try that again. Apologies. Okay, can you see it now on the screen?
We can see it.
Okay, I'll press play to get it started. Okay.
Hello there. Midsteeple Quarter is more than a project. It's a community benefit society breathing new life into Dumfries town centre by redeveloping empty high street properties to create a new neighbourhood with a mix of uses built upon principles of local prosperity and well-being. As part of this, we want our properties to be as low carbon as possible. For centuries, Dumfries has been the principal market town for the region. However, despite its previous wealth and economic prosperity, in recent years it has become a market town with no market, like a coal town with no mine. This is Dumfries High Street in 2012. Many buildings are underused and in poor condition, and the community is demoralised about the state of their town centre. Scotland Government's community empowerment legislation was at the heart of the idea for Midsteeple Quarter. Using initiatives like community asset transfers and community right to buy, we hope to bring these 8 high street properties into community ownership and develop them as a community for the benefit of the community. Previously, this legislation had been used by communities predominantly in the Highlands to buy back land used from shooting estates or islands that were then stewarded by the community. Dumfries was the first to cry that they wanted to buy back our high street. To summarise it, the Midsteeple Quarter vision is to see the local community take control of a group of underused, neglected high street buildings, refurbish, redevelop these as a contemporary, living, working, socialising, learning and enterprising quarter, a new beating heart for a more diverse town centre and a catalyst for a thriving and resilient future Dumfries. In 2018, we held an architecture competition to provide ideas for the concept, which was won by ARPL Architects, whom we now have an ongoing relationship, and they produced the design of our phase 1 of our redevelopment. This master plan was submitted to the council and was approved in November 2019 as supplementary planning policy, underpinned by planning policy in the local development plan 2 for Dumfries and Galloway. In 2022, it won Master Plan of the Year at the Scottish Design Awards. A total project cost of about 25 million is envisaged, and it's intended as a long-term project over the next 20 to 25 years. The master plan includes a phasing plan showing phase 1 currently under construction and fully funded. Phase 2, site assembly through purchase and meanwhile use of other high street frontages and backland. Phase 3, the development of those high street frontages and backland. And phases 4 and 5 are not necessarily considering acquisition, but working with the current owners of the properties. This phasing has been carefully factored into options and plans for how we provide low carbon heating for the site. Phase 1 of the project started construction in June this year with a programmed completion date in early 2024. We took ownership of this building through a community asset transfer in November 2018, and the redevelopment will provide a range of flexible business, cultural and community spaces on the ground and first floors and 7 affordable flats to rent on upper floors. The Midsteeple Quarter team, the Phase 1 design team and Local Energy Scotland sought to find ways of minimising the carbon footprint of the Phase 1 development during the design phase. And given that the proposed flats were to be for affordable rent and much of the commercial space would be rented to enterprise startups and community groups, we also wanted to keep bills down as much as possible. This foresight has proven invaluable given the current energy crisis, as well as being motivated by net zero targets and climate crisis concerns. All of the usual renewable energy sources were considered during the design process, and solar PV will be put in the roofs. Dumfries overlies the only significant Permian age basin in Scotland, the youngest and therefore least compacted sedimentary bedrock type in southern Scotland, and includes a warm water aquifer. Previous boreholes in the region and studies commissioned by the local authority indicated that this could have the potential for geothermal energy extraction. With funding from CARES, the development of a proposal has taken forward on the aspiration to create a district heating system using geothermal technology related to this unique geological opportunity. This has enabled us to engage the services of Locogen consultants to advise on the potential of this and manage the process of taking it forward. A feasibility study showed potential for substantial heat resource from the aquifer. Funding secured by CARES and the Energy Redress Fund is enabling us to take forward the drilling of 2 test boreholes in Dumfries High Street. This will shortly be going out to tender. In the meantime, the planning for this has included statutory consents such as planning permission, etc., and liaison with SEPA, Scottish Water. Interestingly, part of the reason for there needing to be 2 boreholes, even at the test stage, is that we need somewhere for the water from the aquifer to discharge to. Scottish Water would not allow us to discharge into the combined sewer because it expects that there will be significant volumes that would be too much for them to take. And so the second borehole allows us to discharge back into the aquifer. Tests of yield from the boreholes will inform the design of the heating system for phase 1. However, it confirms that such a system will work. If it confirms that such a system will work for a system at this location, We plan to not only heat phase 1, but install the piping infrastructure in the High Street now, so that over time we can create a district heating system for the whole Midsteeple Quarter and potentially the wider town centre too. The benefits of this will enable us to supply affordable heating to our buildings and, depending on the yield, the wider town centre too. Midsteeple Quarter has an ambitious vision for the High Street regeneration. You can sign up via our website and keep informed of our pioneering journey as it continues to move forward. Thank you very much.
I hope everybody enjoyed that. David Lindsay-Hood from Lacogen is now going to tell us a bit more about the technical sides of that project. David, do you want to share your own slides, or would you like us to share them for you?
I can share them. Seconds. He says very optimistically. Okay, hopefully you can see that.
Yeah.
Yep. Okay, so thank you very much. I'm David Lindsay-Hood, and I'm from Lacogen Consulting, and we've been supporting the Midsteeple Quarter project since for at least 2.5 years, going through the progression that was being discussed. So it's been very exciting and interesting to see how this project has developed from that initial sort of feasibility master plan through to the state that we're at. So Scott's given you a good oversight from the community's perspective. Iona asked me to talk through how some of the technical aspects we'd looked at have come forward. So I suppose from a consultancy point of view, it's quite an interesting and unique proposal that Midsteeple Quarter puts forward, because it differs in many respects from a number of the community heating projects we've looked at and some of the other renewable energy schemes that we get involved in, because this is it's an urban regeneration project. It's phased across multiple buildings over a long period of time. So it needs to have that consideration of both what can be achieved now, but how those stages are going to impact the later development, so that we can have a scheme at the earliest stages that's going to benefit the long-term vision. And that's something that CARES were bought into and were able to then support Midsteeple Quarter in delivering. So our challenge was to try and understand how all that where it was going to fit together, which has been fun, complicated, but fun. So we, at the earliest stage, what we had was the architect's master plan drawing. So we had to take that information and we had to understand what that meant in terms of heating profiles, in terms of electricity profiles, in terms of what those demands were going to look like throughout the year and across the different building types, so that we could start to get a handle on what the renewable energy options were going to be. So we had to look at all generation types, but it became clear pretty quickly that PV and some form of heat pump were going to be the predominant options that we could look at. Given the inner city nature and the layout of the buildings, we're going to maximise the opportunity for PV on the roofs, but there's little more. It adds a proportion of the energy demands, but it is not as much as sort of the full demand could be for the buildings. But it will supplement how the building energy requirements. The bulk of the work that we've been doing has been looking at the heat delivery portions of the project, because with the intention that as these buildings get built, there'll be no gas, and we wanted to look at the zero carbon or the low carbon heating options anyway. We knew that we were trying to compare predominantly the direct electric or air source heat pumps as the base case, as the sort of business as usual. So when we looked at it, you're trying to think about what would be the case if you did nothing else. And the standard for this would have been a series of small individual air source heat pumps, which adds if you were to have that for the location, you saw the drawings that were laid out, it's actually quite constrained. You would have all of those individual air source heat pump units stacked up a 3 or 4 story building at the back that has access issues, noise issues. Hope you can't see David's slides. Oh dear. Hopefully some of you can see my slides.
I can see them.
Oh, that's all right. Okay. To the person that can't see them, I'm really sorry. I don't know what to say. Hopefully my face is exciting enough. So you would have had this sort of a cumulative effect, and you've seen buildings where they have lots of air conditioning units with the units mounted over the back. There's a noise, there's a visual issue associated with this. So for a variety of reasons, that would not be the preferred solution. So we were looking at different types of centralized systems, something where we can look at both combining the operation and maintenance to reduce the amount of impact, and also to allow the community itself to own and have the benefit of some of the generation to provide heat to the different clients. So there are options for both centralized heat air source systems and for ground source systems. But as Scott mentioned, Dumfries has a sort of an interesting geology. It had been flagged in previous studies that there was the potential for what's called an open loop aquifer scheme, where we pull water out of the aquifer, put that through the heat pump to abstract the ambient low temperature heat, and re-inject water back into the same aquifer. So this is more efficient in some respects than the sort of traditional ground source system, because you're getting that direct heat exchange with the groundwater itself. It has other issues, such as we have to have the right pumping equipment, we have to have the right filtration, but it's something that provides quite a unique opportunity for us to explore in this situation. So as you said, there are sort of two topologies, two options that we looked at. One is where you can have either an air source unit driving a low temperature network with individual heat pumps in each building. So the initial air source system would provide that base load heat, and then each individual flat would use its own heat pump to drive the temperature up to the demands that they require. This is a system that's been used in London, a few other places where they have sort of where they can't access groundwater, they don't have access to other low temperature heat sources, and that's been the sort of the alternative, the fallback technology for the site here. But what we really wanted to explore was the aquifer system, which is the one on the right. So which is where we're pulling heat out, pulling the water out. Now, we don't know exactly what that temperature is going to be, but we anticipate it to be around 10 degrees, which is pretty good for ground source systems. And if, as is believed, the aquifer is mobile, then that will recharge. So one of the issues that you see with ground source systems, where it's a closed loop network, where it's just pipes in boreholes with the water running through those boreholes, is that if it's not designed carefully, you can slowly extract more heat, and the temperature of those ground loops can cool slowly over time. Whereas with a mobile aquifer, water is passing through and refreshing the energy that's being pulled out. So you can maintain that same input-output temperature differential through the operation of the system. So it's quite an exciting, quite an innovative and interesting scheme that's being looked at here. But it's complex. With closed loop systems, it's much easier to understand. We just need to know what the geology is going to be, and you can work out what the heat transfer coefficients are likely to be and the number of boreholes. For something like an open loop system, you really need some people that understand it. There are only a few organizations that have the kind of technical skill and have been involved in these types of projects that we can bring in to advise us on the technical details of that subsurface geology. So we brought in a specialist consultant, Carbon Zero in this case, who did the hydrogeotechnical studies and designed how those borehole systems would work so that we could abstract the heat that we need. Because again, we're not looking at providing a system that's just going to feed the stage 1 building, but enough water pulled out the aquifer that we can provide for all of the phases of the Midsteeple Quarter development. So it's a bigger, more complex system because we're making that forward planning. So we're looking at drilling 2 holes. They're lined, cased holes. They're much larger than you would see for normal sort of ground source closed loop systems. And they're fitted with a filter pack to stop the silt and the sand from being pulled through. And we abstract from one, suck it up, and then re-inject it back into the other. But as with everything to do with geology, you don't truly all the desktop investigations in the world and the analysis of other boreholes in the area, all that got studied, but you only truly know what happens in your area when you drill the hole. So we worked with CARES and Energy Redress to get the funding so that we could drill those 2 holes. And those 2 boreholes that we're going to drill as test boreholes, they will become, fingers crossed, the live boreholes themselves. So it's not that you drill a test and then abandon it and do something later. The hole you drill is the hole that you test, and then the hole that you will use going forward for that network. So we wanted to understand that the scheme, not just in the isolation of the Midsteeple Quarter development, but in terms of any other future developments, because with LHEs and other Scottish Government considerations around renewable heat, we want to make sure that this is part of the future development strategy. So we were speaking to the local authority. We've been speaking to other developers in the area to understand what their loads are going to be. And they were all very excited and all very interested. And I think it's fair to say that they really want to know how we get on, because they're really keen to do something similar, and they hope that our project turns out well. So it's very clear that if this works, then we expect there to be replication of it going forward in the area. But that they were all very keen that we champion the way and lead the cause to identify and answer the questions that everybody wanted answers to. So we spent quite a bit of time looking at different borehole options. On the left is the first design that we came up with, which was actually to have one at the front of the high street and one at the back behind the first building. So the first building there is the oven. That had the advantage that we were only drilling one borehole on local authority on the streets, but actually we had to change the location during the development because of the phasing of some of the works and also the proximity of that borehole to the building. So we're actually going for 2 boreholes in the high street, an abstraction and discharge boreholes, which will allow us to run the tests. So we had to get that, we had to get planning permission in place. We had to deal with the local authority to ensure that this was all signed up. So we've got all out there. We also had to speak to SEPA, because SEPA are the guardians of that water resource, and they're the people that you need to get the permissions off to ensure that we are dealing with that resource effectively, that we're not taking more out or changing the temperature too much. So as Scott mentioned, one of the issues we came across, because we knew a number of these things would be complicated. One of the things that we hadn't banked on, or at least hadn't thought would be as complicated it was actually the short-term discharge of water for test drilling. So in order to test the borehole to ensure that you can get the water resource that you need, you have to flush it, and then you have to run a pump test on it to show that you can pull the right water out. So we're looking at 14, 15 litres a second, so high volumes for the full development. So we need to be able to pump that water out for 24 hours to ensure that the aquifer can recover if you're taking that water out permanently. So actually that's a lot of water. It's about 50 cube an hour. That's 2 large water tankers an hour of water that we would be moving in the full flow test. And it turns out that the Scottish Water weren't able to offer initially the ability for us to put that into the sewer, even for that short-term test. So we've had to do a lot of work with them to understand and sort of resolve how we can fit around their requirements and what that means, because what we don't want to do is to overflow the sewers, even if it's just for that one day of testing. So it was actually a lot more time and effort and resource had to go into to putting that testing in place and to resolve those issues with Scottish Water. Some of the other issues we had sort of much more sort of easy to resolve, things to do with road permits, closures. A lot of consultation has gone in. This is on MSQ and Nixon, the principal contractor's work in terms of dealing with the local businesses to ensure that the disruption, the noise is kept to an absolute minimum. Because again, this is a community project, we need to ensure that we're bringing everybody on site. And also there's understanding the funders' requirements. There are deadlines and timescales in terms of how the project needs to progress, when the money needs to be spent, what needs to be achieved at each milestone for that. So lots of moving parts to try and keep this project going and get it forward. And it's a testament to the work that Scott and Iona have been doing to be able to overcome all those different hurdles and keep it getting to the stage that it's at. So if this has inspired you or terrified you or a bit of both into doing a project similar to this, there are a few kind of takeaways from this. One is to have that long-term vision. What we see a lot is heat projects which are quite small, and actually small projects are often very hard to pull off. Actually having that longer term vision, to have that sort of bigger picture view is good. It gives you context. It allows you to put in the context of what the wider Scottish requirements are, the Scottish government, the local authority needs are. So I would encourage you to dream big in terms of the projects you're going to do, and consult early. A lot of the statutory considerations that are involved in doing these things, SEPA, Scottish Water, local authorities, the earlier you can have those conversations and flag the type of thing that you'd like to do, the easier, because they will all have their own particular concerns and considerations. And you need to adapt, because whatever plan you come up with at the beginning, there'll be reasons why you can't do exactly that. So we have to adapt and adjust the plan, the locations, the scale, the timescales to fit those. And these things do take longer than you think. So be prepared that it'll require a bit of time and effort. But I will tell you that they are interesting and exciting and definitely worth the effort and resource that goes in. So thank you very much.
Thanks, David. Just before you jump away there, I've got one little clarification which I have tried to respond to in the chat, but it's maybe worth you saying something about. The question is, how sure are you that 10 degrees will be maintained and not diminish over time?
Reasonably sure. Unfortunately, as with all these things, there is no guarantees. There is some sort of complex modeling software that people run to understand what the hydrogeotechnical engineers say is going to be the situation. And as we said, with a mobile aquifer, we are much more confident, because what I didn't say was that part of the reason that you have to have those two boreholes far enough apart is that you don't want the short cycling of water being abstracted and then re-injected and you sucking cold water back through again. So all of the sort of desktop indications are that we are confident that it'll be, that we've done it, so the water is migrating away from our system. But we won't know for sure until we have drilled the boreholes and tested it. So I'm afraid there are no absolutes or guarantees in this, but we've done everything we can to try and ensure that we're doing this with the best available information.
Thanks.
Thanks, David. And next up, we've got Lisa from Kensa Utilities talking about the Heat the Streets project. Are you happy to share your slides now, Lisa?
Yeah, as long as I can do this correctly.
Thank you.
So I think I'm actually going to reiterate a couple of the points that David made in his presentation. Heat the Streets was developed by Kensa, which is a business. So we came to this from the business perspective of where we see the future of our company growing. Kensa is a UK business. We're the market lead in ground source heat pumps with over 40% of the UK market. We've been going for over 20 years, and in that time we've moved from manufacturing into design and installation, and now the newest part of that business is Kensa Utilities, which is looking at the ground array infrastructure that serves heat pumps. So we are still the UK's only manufacturer of ground source heat pumps, and this image that you can see on the screen now is the factory, which is about 3 miles from where I'm sitting, which is just outside of Truro. And that's 4 miles from Stydians, which is the focus of Heat the Streets. The history of Kensa was that the founders were building ground source heat pumps in a garage, basically. And to start with, they were building heat pumps that were going to self-build architects, people building luxury, one-off buildings. They then developed the shoebox heat pump, which was the smallest and quietest on the market. That comes in 3 and 6 kilowatt versions, which is suitable for social housing properties, much smaller dwellings such as flats, bungalows and smaller houses. And that allowed Kensa to move away from just those individual sales into wide-scale deployment in social housing retrofit. From there, they broke into the new build market, which is also served really well by the shoebox heat pumps, because the heat demand on a new building is generally lower than that on an existing private retrofit. And then the future of the business is moving into wide-scale private retrofit across the existing homes in the UK now. So there are currently 29 million homes across the UK that all need to be decarbonised if we're to get anywhere near net zero. The current barriers to decarbonisation that we're seeing are mainly around the really successful rollout of natural gas in the UK. So we've got a fantastic gas network. Gas boilers are really cheap. It's an absolutely huge market. It's really easy for people to replace their fossil fuel boilers. The upfront cost of renewable heating is really it's the biggest barrier that people see, especially individual homeowners. And the complexity of the market. So if you imagine yourself trying to arrange a ground source heat pump installation into your property, it's really quite a big project, and it's a big issue to navigate that on your own. And the other issue we have is that people frequently replace their boiler when it breaks, and that's not really possible if you're looking at renewables, because you tend to be looking at 3 months plus lead time to get anything installed, and not many people are going to wait that long. So the Kensa vision for the future is split ownership, ground source heating installed street by street. So rather than individuals going out and getting their own air source heat pump or their own ground source heat pump and their own ground array, we would have town-wide ground arrays that people would be able to connect to when their boiler breaks. It is a form of district heating, but it's an ambient temperature system. So again, it's round about 10 degrees Celsius, certainly in Cornwall. And that can drop over time, but if the ground array is sized correctly, we should be able to maintain that, especially if we introduce cooling to that array, because the ground array can provide cooling as well as heating. Each house would have an individual heat pump in the same way as David was describing for their system. And the basic setup would mimic the gas network. So you would be able to connect when your system breaks. You wouldn't have to pay for that high upfront cost of installing the infrastructure, which doesn't require any real maintenance. It's very stable. There are no moving parts, and the infrastructure will be there for 100 years after it's installed. It's just plastic pipe, the same pipework as the water utility providers install. And this creates a really fantastic opportunity for private investment. So it's difficult as a business to have your business model based on the grant funding, which tends to change every 3 years or so. So the further away we can get from that central government support, the more stable our business is going to be. Now, how we got to heat the streets, I've actually been working on this personally for several years now. The original project was to deliver a village-wide heat network in Porthleven, which would have been a water source network, but using marine water instead of an aquifer. I applied for grant funding from ERDF and HNIP, which is the Heat Networks Investment Project. But both of those turned me down at the time because the project looked so large as to be a risky investment for them, and neither one wanted to be the first to agree to it, and I needed both of them to sign up for me to get that project moving. We were then re-invited to apply for a smaller scale project in lockdown. And at this point, because we'd been given such a tight timescale to turn around the application, we turned to areas that we already had local connections. So we already had some form of community consultation done already because we were involved with the local energy group, the local parish council, and we knew people living in the village. And so we focused our private retrofit aspect of Heat the Streets on a village called Stithians, which is very close to the factory. Now, this is Heat the Streets at a glance. We're offering split ownership installations to 3 different markets in the sector. So first off, we've got the new build installations, which are receiving heat pumps. Now for them, they get ground source heat pump for the cost of air source. The tenant that moves into those buildings after they're complete will pay us £12.50 a month for use of the ground array. For social housing retrofit, again, it's ground source for roughly the cost of air source. And the social housing landlord will be paying £8.50 a month on behalf of their tenants for use of that array. For the private retrofit, they're paying no upfront cost, and that was so that we could fit in with the delivery timescales that we're faced with from this grant funding. But each of those is going to pay us £25 a month to use the ground array. And for every single one of these, they're agreeing to do that for a 20-year term, which is really quite a commitment. And that contract will be passed to the new homeowner should anyone leave. So if the social housing property is sold to the tenant, that payment will be passed on to them and the agreement will pass to them. If the private retrofit house if they come to sell, they'll have to pass on the contract to the next tenant of the house. But why would each of these want it? You know, what makes them want to take up the offer? And it's not just the grant funding that we've got. For new build developers, the offer actually provides them with slightly lower upfront cost to an air source heat pump, which makes it much easier for them to deliver the project with low carbon heating. And then they can pass on that long-term repayment to the property owner. And because it's really quite affordable, it doesn't reduce the saleability of the house. For social housing landlords, their particular interest is less in the capital cost reduction and more in the simplification of their business model. So should the homeowner exercise their right to buy, the social housing landlord is not left with the infrastructure that's serving their house. They're not left with the responsibility of that. So they can pass that on to the homeowner and they won't be left with a stranded asset. For the private homeowner, the upfront cost is the barrier of that upfront cost is reduced to them, so renewable heating gets more accessible. It's also more simple because they don't have to do the project management for the whole installation. They don't have to search around the market. And in future, if we're successful with rolling out this across much more of the UK, there wouldn't be no requirement on them to install one of the Kensa ground source heat pumps. You could connect any ground source heat pump to this system and it would still work. So there's a short video here of our very first borehole in Stidians. We did visit this again the next day as a project launch, and actually we did hit some water, so there was not very high pressure, but there was some water bubbling out of that the next day whilst we had all of the cameras there. We've had fantastically high uptake for this across the village. People are really keen to take part in this project, and for various different reasons. So in Stidians, it's an off-gas village, and that means that people there are facing having to find renewable heating from 2026 as the government's trying to phase out replacement of fossil fuel boilers. The next part of our project in Stidians is a shared ground array installed in the road, serving around 60 properties, which are a mix of social housing and private retrofit. It's actually a really complex thing to do. It's not business as usual for Kensa, and it's certainly not business as usual to install a ground array in the road in anything but new build. And in the new build development, you'd put that ground array in and the road would be built on top. There's no issue. It's far harder on private retrofit. Now, in a similar way, we've done a huge amount of consultation and we've had a lot of feedback. And the reasons that people are appreciative of what we're doing vary massively across the board. Some people are really keen on the environmental benefits of the project. Others just want to be able to budget better. So one of the people that we spoke to currently has an oil system that they're not able to afford the upfront cost of the fuel, so they can't get the tank filled. And last year that meant that they went out and had to buy electric heaters for their home, which are far more expensive to run. But it was the only way that they were able to heat their home that year. And that's not the kind of person that would be able to buy a heat pump themselves and have that installed themselves, because the upfront cost is just so high. So it's a fantastic benefit that this is delivering to the village. So thank you very much for listening to that, and I'll be happy to share the slides with anyone at the end of it if they want to.
Thank you, Lisa. So I'm just going to finish the presentation session with a quick couple of points about this new community heat development programme that we're planning to launch later this year. Just pull up a couple of slides for that. Hopefully everyone can see that okay.
Yes.
Thank you. Okay, so it's this is some provisional information that we're sharing, and it may change, but we wanted to let everybody know what the plans are, and you can stay in touch with what we're doing with updates via our website, social media, and you can sign up to the monthly newsletter if you'd like to. The plans at this stage are to support eligible community organisations and groups of householders, and there'll be technical support provided to appraise the feasibility of communal heat projects. And it'll be very much a learning programme, and if budget's available, we're expecting this will run until March 2025. Examples of perhaps some of the sorts of community heat projects that could be looked at include a community-led heat network for an off-grid gas grid village serving multiple homes and perhaps a neighbouring business, a collective heating system for a group of neighbours in a block of flats, or maybe a collective purchase of heat pumps and energy efficiency measures by a climate action group. So as I mentioned, this is a new programme for CARES, and it's a programme very much where we want to learn. And our aim is to find and support replicable models for community heat decarbonisation projects. We'll be learning as we go along from the findings of the studies, from the experiences of the communities and the expertise of the companies that we work with. The findings will map out next steps for the community projects, and we'll use this learning to create supportive tools and resources. And we'd very much welcome your thoughts and ideas in the question and answer session we'll just go into. While we're mobilising and launching later this year, there's other steps that communities can be taking. Home Energy Scotland is a fantastic resource to provide householders with advice to reduce energy bills and improve energy efficiency measures. You can be collating information to understand how much you're using and how much it's costing. And you can be talking to neighbours to gauge interest and see what could be done as a collaborative approach. So if you're interested in the community heat development programme, please feel free to register this interest by completing the inquiry form on our Contact Us page on our website.